Hi, I wanted to give you a quick run through of how to use your inverse trigonometric derivative rules. So you might see inverse sine of x written this way. You might see inverse sine of x written this way. Two different notations for the same function. By now you should know that the derivative of inverse sine of x with respect to x is 1 over the square root of 1 minus x squared. We can make a more generalized form. If we're talking about the inverse sine of some other function, maybe this is x squared, maybe this is 5x, maybe this is the natural log of x. If you want to take the derivative of inverse sine of any function, we're using this idea, but we'll also use the chain rule. So that's going to be 1 over 1 minus whatever this function is, squared, times the derivative of that function. So that's the chain rule. Let me show you what that looks like. So if you ever come across a problem like this, hey, the derivative of inverse sine of x, that's just using this rule. So you just write 1 over the square root of 1 minus x squared. You don't have to reprove that every time. What would you do if you had the derivative with respect to x of inverse sine of 3x? So I'm thinking about my rule. That's going to be 1 over the square root of 1 minus something squared. 1 over the square root of 1 minus my input, 3x. Which is squared, and then the derivative of the input 3x, 3. You need to multiply that times the whole function using the chain rule. Let's look at one more. The derivative with respect to x of inverse sine of x to the fourth is still going to be 1 over the square root of 1 minus something squared. Let's see, what's going to be squared this time? X to the fourth is the function that's squared. And then you need to multiply by the rate of change of x to the fourth, 4x cubed, using the chain rule. I hope that helps.